Today we see the sound. Next other type is not going to capture this. If we have to be having or today we going to see the sound. In sound now, already you can study. The extended study. It's like education study. No, I don't. अभी तक नहीं है. What is sound? So how many dragons may have a longitudinal? So compression, transaction, you can know what is longitudinal, what is maximus. In this some chapter with study of the echo. Okay. There is a three condition to be. Okay, what is here? If I am a transmitter, I am the source which gives sound. My reflector actually it was patterned by the reflection of sound. Reflection is nothing but incident ray is equal to the reflection. Because whatever shows I should get it back. It is the back of the sound. Same vector like that. So when my reflector should be obstacle should be larger than the first condition, the obstacle should be larger than. Then what is the other condition? It minimum we should have a sound emitter. And third one, we should get the sound back at least minimum 0.1 seconds. Okay. So if you how we need to calculate the distance now, the echo formula is how to find the speed. What is the formula to find speed? Distance upon time. Okay. So in echo, 2D by D. Why 2D? So the voice going and reaching the obstacles, 1D, and coming back again under D. So 2D divided by D. Okay. Echo formula is for 2D divided by D. If you substitute with the value of the speed of the sound is what? Sometimes somewhere they mention 330 and somewhere they mention 40. If you get 340 also, you will get substitute according to the condition 0.1 seconds, you will get 17 meter. If you put distance 17 meter, you will get 0.1 seconds. Then go reverberation. If you remember the reverberation, so the multiple reflection of sound happens because reverberation. And for sonar, for that time we use ultrasonic waves. Okay, why we are preferring ultrasonic? So it never deviated. It is undeviated. It's confined to the narrow field, and it never be easy absorbed. Okay. Then in actually now auditorium unlock, how it would be used. It's not allowed. So it should be smooth and hard. It should get that camera. We should get the bus roads. But reflection should not be hard. Instead, they will do it. In the recording system, they will precautionary, they do structure. See, in classroom, they used to put curtains, in order to avoid that. So there are some precautions we are doing. So in when it is absorbed, the reflection will be very easy. So that side in classroom, say put curtains, keep benches, and mat, door mat. It will absorb in empty classroom now. If you raise a voice, you will get back more level. Okay. So in these things and all now will absorb the sound. So reflection of sound never be happen that much. Okay. In vibration, there is the three types basically. the natural vibration and forced vibration and the lateral vibration. Natural vibration, and it doesn't need any external source to be active. It doesn't need external source. It vibrates. Okay. See, I'm not giving any source, but sometimes it will be it will be vibrate. It happens naturally. So I'm not giving any force. Force vibration, if I'm giving force, for example, in swing now, if I'm pushing, then only the swing will, isn't it? So that is force vibration. And down vibration is nothing but we initially the force vibration. At some point of time, it will be equal to the natural vibration. See, in natural vibration, it will vibrate very slowly only, not Joseph. Joseph vibrating, it only happen by the force vibration. In damped vibration, what will we do now? It start after giving it initiate by the force vibration. Okay, after experiencing force vibration, Joseph will speak. Okay. After some time, it will come to the natural frequency, okay, natural vibration. Okay, it's a process going right, it is damped vibration. And at last it will end. Okay, at last it will end, stop. Okay, so that is damped vibration. Resonance. Resonance is nothing but it will be continuous. Okay, it will be equal to the natural vibration. Okay, Joseph will happen at some point. It will come back to the natural vibration. Okay, but it keep on repeating. That is resonance. And the characteristics. It depends. See, whenever you see in old time, they keep the radio system involved. In the radio system, you can see the light. The light keep on modulating. So, coming. First day, sir, अभी तक she didn't or she is not in competition. Okay. Turn on your video, ma. Today is your first class now. Am I audible? Am I audible?
Yes, ma'am.
Okay, today is your first class, isn't it?
Yes.
Okay. Today we're going to see about the sound. Okay.
Okay,
Just we
ma'am.
are doing revision about the sound. Okay.
Okay.
What you people know about the sound? It happens due to the vibration. Okay. So when the vibration happens, we are getting the sound. Okay. So in that, and I'm giving important topics to be covered. Okay. This is just a revision part. Then in this echo, we're going to see. Okay, there are three basic conditions to be echo to be followed. Okay, the first condition, if I'm the source, I'm giving this sound now, my obstacle should be. So it basically happens according to the reflection of sound. Already we know what is the loss of reflection. Loss of reflection is what? Whatever the incident ray is equal to the reflected ray, isn't it? So whatever sound I am giving, I should get it back. Okay? It's according to the law of light. Okay? So it represents the light equations, light laws. Okay? The incident rate is equal to the reflected ray. Same thing. In the sound also we're going to see. In the echo. Okay? So if I am giving the sound, I should get back the sound within 0.1 seconds. Okay? Within 0.1 seconds. And minimum, see, here I am giving the sound. The obstacle should be minimum 17 meter. The distance should be minimum 17 meter.
and obstacle should be larger than me. Okay. What are the three conditions? I should get back the signal in 0.1 seconds and distance should be minimum 17 meter and that obstacle should be more larger than me. Okay. See what is the formula of echo now? How we calculate the speed distance by
time.
echo is what? If I'm giving the sound, it will reach at this point. Okay, 1D. After reaching here, it will come again back to me. So another T. So 2D by T. This is the formula of echo. Okay. So speed is what? The speed of the sound is what? 2D by T, which happens in the echo. So if in order to find the distance, you can go with the speed of the sound. Basically, it will be variable from 330 meter per second to 340 meter per second. If you substitute these value into this, and if you put this condition, you will get 17 meter only. Understand what I'm saying? You want me to repeat it again?
No, ma'am.
Okay. Then reverberation. What is reverberation? What is reverberation?
I've never heard about it.
It is multiple times of reflection of sound happens. If I'm saying silence, 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 a second, you getting the same sound again and again. So reflection of sound happens multiple times. That is reverberation. Okay. So and another thing, have you heard about the sonar? Sonar is a device.
Yes.
Okay. So it occurs in the principle of reflection of sound. It's nothing but echo. Okay. So whatever the source you are giving, we usually prefer the ultrasonic waves. Which wave? Ultrasonic wave in the sonar. Why we are preferring ultrasonic wave now? It never be and it will be undeviated. Okay. And it confined to the narrow beam and it not be easily absorbed. Okay. For these three conditions, we are preferring the ultrasonic waves. Okay. Then this is a formula for frequency. We know frequency is inversely proportional to the time period. You know about the waveform. We
Yes,
prefer
ma'am.
always in sound now we always prefer the sine wave. Okay. Actually, in sound now, what is the audible range? 20 to 20,000. This is the audible. Okay. I am saying as Sony. Okay. And ultrasonic is above 20 kilohertz. This is ultra. And below is what? Infrasounds. Okay. So the waveform will be in this manner. Is it? It won't be complete also. Okay. In ultrasonic, is it in waveform? So always in sound now we prefer sine wave only. Okay. In ultrasonic now it will be in this manner. Okay. You know about the frequency, lambda and all you know now, wavelength, how to calculate. You know. Okay, then vibration. Actually, the vibration there are basically three types: natural vibration, forced vibration, and damped vibration. Okay, you know about the part. You want me to explain it again?
Ma'am, can you explain it?
Okay, I do. Okay, say natural vibration is nothing but it happens naturally. Okay, it doesn't need any external force to be occur. Okay, when it is occurred naturally, it is natural vibration. It doesn't need any external force. Okay, then forced vibration, it need one external force to be occurred. Okay, that one is forced vibration. Damped vibration is nothing but initially it experience the forced vibration. At last, it will come, at last it will come to the end. Okay. Initially it will vibrate more, then medium, then at last it will be end. That is what damped vibration. Resonance. Resonance is nothing but it experiences the forced vibration. At last it will come back to the natural frequency, natural vibration. Okay. Understand the resonance and characteristics of sound. The basic three characteristics. How to alter the loudness. Loudness is our voice. Okay. See, if I'm talking loud, okay, I should adjust my amplitude. This is amplitude. I need only to adjust my amplitude in order to reduce my sound or increase my sound. I need to adjust only the amplitude. The frequency is adjustment regarding the pitch. Okay, pitch will be alter the frequencies. Okay, amplitude is what? Loudness. Okay, it will be measured in decibels. Okay, there is a formula. Intensity, how clarity is in that voice, in that sound. Okay, so that is a formula in that loudness. Then draw intensity 1 by intensity 1. Okay, you can consider this. This is the formula to find the intensity of that, and it will be measured in decibels. Then what are the things have to uh, the speed of the sound depends on elasticity and the density. Okay, you people already studied about that. So I'm just covering the syllabus, whatever things I have asked in the test. Okay, Jeshwini, I'm going to share you one Word document to you. Okay,
Okay, ma'am.
you just need to answer those things and you can correct it by yourself. Okay. Mm. Then this and all we have done this one. Actually now when we can detect the sound, actually we can do it by 10 power minus 2 watts per meter square. Okay. If it is below this, we can't, it is not audible. If only it is base is this. In decimals, we can hear 0 decibels also. Okay. So that much we can hear. So basically, we can hear 0 decibels. That much sensitive here we have. Okay. Then sonar we have known. Okay. In natural frequency, that is a formula. So F equal to 1 by 2 pi root G by L. G is what? Gravity. L is length. Okay. The whatever the formulas I have mentioned here, just go through once because the questions will be coming from this things. Very easy questions only I'm asking, very basic questions only asking because you people are ninth standard now. You can do revision.
Sound. Only question, others are word of no Sharika. Only question. Party question, everything like this. I can assess from there. You could. We only see attention there. मेरा किसी भी का practice तो मेरे लिए ऐसा करना sound का sound only question लेकर instead also you look at the knowledge. I say you have instead we more advanced skills. They need that this is also basic. Okay. This year more technical in telecommunication how we are transferring messages. Okay. Actually now sound now everywhere we are using. In imagine we have military purposes. How they people communicate. Military people, police people will be available in all over. India. So we used to choose one particular frequency. For their communication will be one particular frequency. Our communication are radio on there are different frequencies. If you have listened in our radio, the 91.35 Surya FM. They say that is a frequency to follow the radios. Okay, they take this is section for them. Is it? So in like that way, we can the communication will be happen in military purpose. In all police station, if you see that there is a mission will be available in that police station. In that you can see frequency mentioned in the radio itself. Okay. In that particular frequency, we can connect all over Tamil Nadu police or else or all over Maharashtra police. They say there is a one particular frequency. So one particular frequency, this people can communicate. Overall, people can communicate. Some locality. They say state wise we can communicate with one frequency. They say it is possible. How we are tuning it, that matters. Okay. If you tune into other, na, we can't get it. Exactly 99.1, na, we have to tune according to that. Then only we can connect to all the police station. So whenever we are talk, it's like intercom. So everyone can hear those things. If others talk, every other people can listen to that. So in military purpose, now other way we can see, I have done my project in my engineering. How I have done my project, now the message should be reach my friend. Okay. Imagine my friend in Kanyakumari, I'm in Kashmir. Okay. We both are police. Okay. The message will be confidential, isn't it? So what I do, I take one baby image. Okay. So in baby image, I'm merging information. It's like this or the terrorist. I'm mentioning the image of the terrorist. Okay. Or else information of the terrorist along with the baby image. Okay. I'm merging it. So I'm merging and sending that. Okay. That
image will be transferred from me. Okay, transmitter I am, isn't it? I only know and my friend only can know. Okay, so that is the information in that. So in between she coming and seeing my message, but what will she see? She see only the baby image, not my image, message, isn't it? So we can say pseudo code. Pseudo is matlab false. Okay, false. She can see only the baby image, but I am merging what my personal information, communicating with my friend. So one receiver now, my friend what she will do, decrypt the data. Okay, so we should know the program to decrypt it. I should know the program to encrypt. Encrypt matlab combining the things, the message as well as the image. Okay, this how we can transfer the images from information from one place to other. Okay, so like that way we can send sound also. Okay, voice message also we can share. So many possible ways to do communication. Mainly we are wherever we are using telecommunication things we are using in radios, the systems we are using, and may in day to day life we are using. Okay, so these things are not basic. How to adjust the amplitude? Or amplitude, if you adjust now, what it will affect? It affect the loudness. They say. So the technically, more technically, we will study in the upcoming weeks. Okay, the next year we study wherever we are studying, wherever we are implementing. Okay, so in depth, technically, we see that. Well. Uh, okay. Yeah, oh, thank you, thanks. Okay, yeah, I see. वो दोनों पीडीएफ बनाया और थैंक यू सो मच Hey, I can't access my PC. Oh my god. I can't access my PC. What to do? Yeah, PC later. Okay, wait, I tried. Ishar Kala. Ashwini ma'am का PC I can access. Ashwini ma'am का Ashwini ma'am का PC है. दोनों अश्विनी मैम का PC है. हाँ सनी सर का है. ओके ओके डी फोल्डर. Foundation. Ah yes. Science है. Yes yes. मीना बट ये पी वर्ड डॉक्यूमेंट है ना. हाँ 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 वर्ड डॉक्यूमेंट मिला. मुझे पीडीएफ चाहिए ना. स्टूडेंट ऑनलाइन से. हाँ दिया है. थैंक यू. हाँ मिला मिला. Okay, Jayashni, I am sharing you one question paper. Okay, try to solve.
Okay, ma'am.
You able to see the PDF?
Yes, ma'am.
Jayavashni, you done?
Yes, ma'am. Last two questions.
Okay. Want to check? Want to check the questions? Cross checking the other. Online. Okay. You done now? Jayavashni, you done?
Yes, ma'am.
Okay. Shall we discuss the answer?
Yes.
Okay, what is the first answer? What is the first answer? The bouncing back of sound after striking a surface is called reflection.
And
Okay. The law of reflection of sound states that angle of reflection is nothing but angle of incidence is equal to angle of reflection. Okay. The sound waves obey the reflection law similar to
light.
okay. Jayavashni, I'm sharing you model answer.
Yes, ma'am.
Okay. Then fourth one, echoes are best heard when the reflection surface is smooth and hard. Okay. So and fifth one, the minimum distance echo in air at 20 degrees Celsius is approximately. Anyway, it should be minimum 17 meter. Okay. Then what about sixth one? If you substitute the formula values in the formula, you will get 17 meter only. And seventh one is an echo is heard 0.8 seconds after sound is produced. Distance of reflecting surface is what? Oh, you're using the model answer. If you do discussion, it will be more is revision, more than revision. Okay, keep it aside. While doing revision, you can correct other step. Okay, the seventh one is what? 136 meter. Okay, after substituting the value, we'll get that. When temperature increases, the speed of sound also increases, directly proportional. And echo is prominent in the large empty hall because less absorption of sound. Okay, the repetition of sound. So the multiple reflection is what? Reverberation. Actually, it is very useful for you, na? Full of 10th syllabus. You people doesn't have this chapter in your 10th standard. Okay, but it is basic. You can know. And the reverberation is depends mainly on size of room. Okay. And the material reduces the reverberation in a recording studio is soft curtains. And the marble and all, and the glass, concrete and all hard. Okay, so the reflection of sound will occur. In classroom, reverberation can be reduced by. Okay. The minimum time gap between the sound and echo for distance hearing is 0.1 seconds. Okay. And what about 50th one? You have to substitute only the value and get the answer. The temperature. And 16th one, bats use echo, locate rate. Okay. Dolphins use sound reflection mainly for navigation and locating prey. And sonar stands for sound navigation. Very good. And 19, which formula you will use? Depth is what? Depth is what, ma? Here they are given the depth. Okay. So distance. We can say height. Okay. So if by you are substituting that values in the formula, echo formula, na, you will get 2250 meter. And the 20th one, echo not heard in the small room because distance. The multiple reflection of sound causes okay. Persistence of sound due to the repeated reflection is called reverberation. Okay. A boy claps and hear the echo 0.5 seconds later. The distance is what? Maybe 5 meter. And if the distance doubles, the time delayed between the sound and echo also. Okay. Then in sonar, transmitter and receiver are placed in. Yes. Because now when they keep together only they will get the distance equal. So transmitter we are sending one distance and receiver also the distance should be same. That's why the formula 2D. The ultrasound waves used in the sonar are okay. Which sound cannot produce an echo? Tree. And fishermen use echo to locate fish. Okay. For a distant echo, reflector surface must be at least 30. Yes. What about 30th one? A bat emits sounds here 0.01 seconds later. Distance of instant. 1.7 meter. 2 and 4 motion of body, where it will be occur. It means oscillation. Okay? That one is oscillation. You're going forward and coming back. It happens in the oscillation. And the number of vibration per second is known as frequency. Time period taken to complete one vibration is called time period. Okay, natural frequency, body depends on is very good. And 35th, your body vibrating freely without any external forces said to be very good. And vibration that gradually died out due to the loss of energy is called damped vibration. Vibration produced under the influence of external periodic force are called forced one. Okay, when the frequency of forced vibration is equal to the natural frequency of the body, the phenomenon is resonance. The amplitude of vibration at resonance is maximum. Okay, initially it requires what? Forced vibration. Now, that time the frequency will be maximum. Okay, a tuning fork starts vibrating loudly when another fork of the other same frequency is start with the example of resonance. And what about the 41? A vibrating body transfers the energy to the surrounding air molecules in the form of sound waves. Okay. Which of the following is an example of natural vibration? Yes. All other things now they need the forced vibration. The damping of vibration is caused due to friction and air resistance. And the singer status that reacts by voice is called example of resonance. When the soundboard is used in a musical instrument, it works on resonance. Okay. And if you, which formula will you use suitable for 46th question? Tuning fork produces the frequency 256 Hz. Time period of vibration is frequency is what? Inverse of time period. Okay, if you substitute that, you will get 0.004 seconds. Write it in the corner. If it is wrong, write it in the corner. Which formula? Frequency is inverse of time period. Okay, then what about the 47th? If the body completes 50 vibration in 5 seconds. Okay, 10 hertz. If it is wrong, correct it there with the formula. Then 48. When the vibrating tuning fork is kept on the table, the sound becomes loud due to resonance. Damped vibration amplitude is what? Decreases with time. The forced vibration are useful in producing resonance. Very good. The pendulum swings lower on the moon than on Earth because okay, which formula will suit? Either the given the pendulum swings lower on the moon than on the Earth because gravity is less. Okay, we already received one formula now. The natural vibration F equal to 1 by 2 by root G by L. Okay, so if you consider that, then gravity is less. So you can write it there, that formula. Yeah, then
This 46th question, answer is this also.
yeah, that will.
But in the good answer, it was this one, right? But this one is also the answer.
Okay, then what answer they probably they are round of here. How 5 की बार 5 को ऊपर 39 ना that 535K ऊपर ना you can do it round off ना so that then you can give answer this also right away. Which one? Question number
46.
question number 46. You what you wrote? B. 46B. Okay. Actually, they are round up here and this is correct. This both are correct. To give mark. And which one we are now discussing? 52. Okay, the number of vibration per second string is determined by length tension. Okay. So the phenomenon of one vibrating body setting another into the vibration is called forced vibration. Okay. Uh, at 54, amplitude of vibrating body decreases due to damping. You people know about the sampling. Actually, now sampling is like a combination of combining the signal. As in communication, now we using if you plan to do engineering, now you will get digital communication lab. Okay, in the digital communication, what is the first thing they will teach you? How to convert the signal into digital form. Digital is nothing but zeros and ones. Why we are going with the digital now? In order to reduce the loss of sound, I mean signals. Okay. Why we are converting that? The loss will be very less. Only on and off, zeros or one. Okay. See how the digital will be like zeros and ones now. If nothing is representing now, the waveform will be in zero. If they are representing now, the waveform will be go. Your waveform will be in sine wave. Okay. Mostly, whatever the signals we are give, they prefer only the sine wave. Okay. So what sampler will do? Sampling we say sampling. Okay. Sampling will say it takes the digital, or else we can go with the square wave itself. Zeros and ones. Okay. It will be 1, it will be 0. It will be 1, it will be 0. 1, 0. Okay. Same thing. 1, 0. 1, 0. As I we can take digital format 1. Okay. And sine wave. If you if you mingle now, you will get the waveform in this manner. Encrypt okay. So whatever the signals you're in, already I told you one example now how to encrypt the image with the message. Same thing, whatever the message you give, it may be the sound, it may be the image, it may be the message. We have to initially it will generate in the sine wave. Okay, then it will convert into the digital format. Okay, we encrypt the data first. And the receiver side, they will decrypt matlab splitting the data to the original format. Then they will get the receiver side. Exact signal. What the signal is sine wave. They will get receiver part. Damping. Okay. So then what about the 55th question? The pendulum has a time period of 2 seconds. The frequency is
1.5.
okay. 56. Okay. Then 57, the forced vibration, the amplitude depends on both. Okay. And resonant body vibrates with forced frequencies. Okay. Which of the following is a practical example of resonance? Tuning fork. Tuning fork. Okay. Then 60. The vibrating object cannot continue vibrating forever because Yes. Loudness of sound depends on amplitude of vibration. Pitch of the sound depends on frequency. Which unit is used to measure the sound intensity level? Decibels. The quality of the timbre of the sound depends on waveform. If waveform is not coming achana, it will be this coming exact now. So the quality of the sound is good. If you are getting the in this manner waveform now, the quality of the sound is not good. The subjective perception of the loudness varies because yes, very good. Two sounds have same frequency, the amplitude, but the waveform differs. They will differ in quality. Very good. The threshold of the hearing corresponds to 0 decibels. The sounds above which level is considered to be painful. 120 decibels. The noise pollution is mainly due to yes. The increasing amplitude of sound increases loudness. Doubling the amplitude of sound increases the loudness by approximately 4 times because loudness is directly proportional to the square of the amplitude. The frequency of audible range of humans 20 to 20,000. The unit of frequency is hertz. If the frequency increases, the pitch of the sound increases. The tuning fork of 512 hertz is stuck. The pitch is high. The loudness is dash property while intensity is dash property. Subjective and that one is subjective property. The waveform of pure note is usually sine wave. The waveform of musical instrument is generally complex. The sound level in decibels can be calculated using which formula? I by intensity by I. The human ear can detect sound intensity as low as -12. Okay. The sound has intensity 10 per -6 W per meter square. With its sound level in dP is 60 decibels. Okay. So noise can be reduced by yes. Okay. Interdependence of pitch and frequency means high frequency, high low. Quality of the sound depends on quality. Two sounds have the same loudness but quality different quality. This is because we have okay. Subjective property of sound is loudness. Objective property of sound is okay. Noise pollution is harmful because all of these. Audible frequency or range of child is usually same. Okay. Quality. Before note, different note, na? Quality, that one is. Then intensity of sound is energy per second per unit area. Decibels is unit of intensity. Doubling frequency affects pitch. Frequency, na? Pitch. Tripling amplitude affects 9 times. Okay. The sound becomes inaudible when intensity is below 10 power minus 12. I told you now. 10 power minus 12. The ultrasounds have the high frequency. Above 20 Hertz. Okay. Infrasonics below 20 Hertz. And 98. Loudness level is subjective because same intensity sound different to different ears. Amplitude of vibration affects loudness. Complex sounds are generally produced by music instruments. Okay. Now you have to substitute the formula and get the answer. What is the answer for 101 question? 0.3 seconds. Okay. Then what about 102? The sound waves are the wavelength lambda traveling in medium with the speed v meter per seconds and another medium. We have to compare the ratios. Okay. So that time when you compare, you will get 2 lambda. The modern supersonic sea was the planes of the principle of what? Echo. Which of the following does not produce sound waves? Outer space. And what about 105?
Pendulum A, B, and D process.
Okay. Then 106?
17.
Okay. 107?
Echocardiogram.
Echocardiogram. And 108? Quality. 109?
Frequency of pulsation.
Okay, equal to the free vibration of the bond. Okay. Add together. You done correction?
Yes,
Okay.
ma'am.
Okay, add how much, how many questions you got right? Tell me the
Okay.
count.
I'll count again.
Like a division problem. Yeah, I know these people you people use people doesn't understand it. For sure. You people having like she having in 9, that's what is it first. Then then actually both the same. Devashni, how much you got?
Ma'am, I attended 70 questions and I got 10 wrong.
16, na? Next time, you try to get first mark. Okay? Now, either now you are able to see the students sitting here.
Yep, I can.
Okay. In this, now she got a highest mark, 101.
Oh, nice.
Okay. Next time, try to get full mark. Okay, Jay Vishni.
Yes, ma'am.
The second time, na? Next time, you're good. Okay. Next week now we plan to do 2 chapters next week. Work energy as well as the gravitation.
Okay,
So
ma'am.
just in half an hour I plan to give revision. I try to give the worksheets. Okay. Try to do revision, work energy power as well as the gravitation. You're doing 10th right now, isn't it?
Yes.
So you doesn't have that in syllabus, but you people studied in 9th standard.
Yes, ma'am.
Okay. Try to do some revision and try to come prepare for that. Okay. Gravitation as well as work energy and power.
Okay.
Okay. Your parents are coming to pick up you, and you can take care of. Is that how you're going?
I think I got it.
And bye.
Ma'am, can I leave?
Okay.
Thank you, ma'am.
You're bringing this book wherever the house.
I'm very happy.
You will sit here only. Don't go unless your parents are coming. Usually, how much percentage you will get? You people will get in your exams. 90%. In this time standard, you will get views and that time itself will start without for your health. Already, I have taken you the syllabus of 10th only. Current electricity, light, everything I have taken. So again, you do revision daily. Practice previous school question papers. This year itself we start preparing because all the class how we teach now. I have taught you in the foundation classes. Teaching part over. Okay. Moreover, you have to give priority to the light and current electricity. You must answer our pura in current electricity lighting in this ninth year itself. Okay. Then the class starts. Now that time you give priority to magnetism and one more chapter you have human number. Okay. That is also very simple. Then only 4 chapters in physics. Okay. Magnetism, they won't ask that much. Very few questions you ask. Human I also like that one. That you give priority. What I am telling you mainly now, give importance to light chapter and current electricity, the lead section itself. What way of asking question also is they ask any indirect, direct, you have to answer. That much way you have to tell yourself. Okay, I have taught you everything about the 2 chapters. Okay, practice well. If you want any question papers also, you come and ask me. I will follow. I am ready to give you those questions. Practice, practice, practice. Then surely you will get first. Okay. So you people are eligible to get more marks. You don't waste it. Put your works and hard work. Only for 1 year. Okay. Try to study for other subjects also in 9th standards. And I believe try to concentrate on your weak part. If you feel maths difficult, right? Give priority to maths. And then if you go with the maths, you try to give importance to difficult chapters. Anyway, easy chapter you will study, it will come. But in this 9th year now, you give priority to trigonometry and trigonometry itself now, the problem-oriented questions you will get. Not like solving the formulas. It's like a problem, the height of the building. Then it from essay you will get. So height, distance. That time you have to find the angle. That way of questions you have to practice. There are 2 chapters in trigonometry. One is from the formulas, direct. Another one is in the scenario-oriented questions. I'm telling you the scenario-oriented questions give more effort because you will definitely get questions from that scenario-oriented and one or 2 questions from that formula-oriented questions. What I'm saying now, after getting the book, you go through once where you feel difficult. Now you give importance to that chapter and put your work, hard work there and complete your hard chapters first. Okay. Then definitely you will get questions from GST. Before you starting, you ask your teacher in which portion you will get more questions. Okay. I know about physics, I'm telling you, the light and current electricity, you will get more questions. And third priority, human eye, and fifth priority, magnetic. That's what I told you to give importance to light and current electricity. Okay. Many students are feeling difficulty in current electricity. But that is happening in 10th ICs. That I can understand. But then CBSE, it's very easy compared to 10th ICs. That's why I'm saying you people will score much full mark answer. If put your work, hard work, because now it is very easy. Compared to ICs, we can't predict that. Where they're getting question, we can't predict in ICs, but CBSE, mostly it will be the direct questions.
Okay, in maths now, director, pattern, everything same. Only the value they change here. Here they will change the value. Pattern, everything change, everything same. They change values alone. So, maths also easy, physics also easy. I don't know about other subjects. If I know, I can share with you. But what I'm saying now, just give priority to a difficult subject and difficult chapters. Just do time management. Okay, this 1 year. Okay, I want you people to get award from sir. Okay, try to do hard work. Okay, shall I leave? I tell the ma'am and go. Be safe. Okay.